Hey everyone, how are we doing? Sydney's here. Who all is here? We got some coffee. What work are we doing this morning? Like morning, it's 11:30. It's only 10:30 here in Texas. Or 10:40. I know we started 10 minutes late. Sorry about that. I need some coffee. Hey Caroline, good to see you here. What work are people doing this morning? What are you wondering about the project or the assignments? What questions do people have? We can start on either. It's your choice. Good to see you, Jessica. Oh, can we go over another question? Oh, the airline, of course, of course. Let's go ahead and take a look at that. The airline question from chapter 15. Let's go get that question. Let's see. It's sad. Last semester, I stopped drinking coffee and I actually got off it. And now I'm back to 2 cups a day. And I feel it if I don't have my coffee. Like, I don't know if anyone else is like me. Like, if you don't have your coffee in the morning, you're like, oh, I just don't have energy. I just feel like I'm in a haze. And you drink your coffee, you're like, my energy returns. I am back. And then it's it's like I totally have a coffee addiction. No. When you see me on campus, I'll be walking around drinking. Is this a homework? It's quiz good. You'll see me drinking a Starbucks coffee. And you know what? That's really good too. I miss that. I miss walking down to campus. I miss walking down. 100% the same way exactly, Caroline. It's like if you don't have your coffee, you're like, I don't have that extra burst of energy that coffee gives me, that just wake up energy. Let's do this. Let's go over to the quiz here. We're gonna drink our coffee. We're gonna get the energy this morning. We got this. Let's do this. Oh my gosh, there's 15 questions. An organization. Let's see right here. The Null and alternative. Null and alternative. National Vitals Report. It is genuinely believed a philanthropic organization, vital statistics. Oh my gosh, a nonprofit company. Good morning, Kayla. Good to see you here. An airline. Here we go. Yes. Okay. An airline. I am so blind. An airline. You're like, Brian, it's so big. I'm like, yes, I'm looking at screen. I am very nearsighted. An airline's public relations department. Good morning, Katie. Public relations department says that the airline rarely loses people's luggage. Good. It further claims that on those occasions when luggage is lost, 93% is recovered. Oh, that's nice of them. And delivered to its owner within 24 hours. Consumer groups who survey a large group of people find that only 115 of 193 people who lost the luggage on that airline were reunited with the missing luggage. Does this cast doubt on the airline's claim? I think there's a hard part of this question. And the hard part is going to be this one right here. The hard part is going to be state the null and alternative. Now, I just want us to think about this for a moment. This airline is saying 93%. So let's mark the notation and kind of think about this problem theoretically, because there's some easy parts to this problem and some hard parts to this problem. I'm trying to remember the trick to this problem. I'm like, I think I remember. They only say, does it cast doubt on the airline's claim? Oh no, Brian does not have scurvy. Tiny Brian. So when we go right here, it's so small. What is 93%? What is 93%? 93% is what the airline is saying is true. So what is that? And what is this? And what is this? So what is 93%? 93% would be the what? Usually where people get stuck because it's a new thing and we always have to practice new things. I like to do, yeah, of course. Which part of it, Kayla? We'll do that. We'll do Edward's next, and we'll do Kayla's next. So we'll do another My Pearson, then we'll do 320. You got it, Kayla. We'll do 2 stat ones back to it. Great job right there. That is the hypothesized. Exactly. That is the hypothesized, what the airline is claiming. So they're saying that is true. These are X and these are N. As long as we get the ball rolling, we got this. And then we'll go here in P hat. And thank you, everybody. Everyone waits so patiently and puts questions in the queue, and I love that. That's really great. I think sometimes people wait till I'm done with the question to ask. I'm like, oh, just ask. The bar chart. Of course, we'll do that. We'll do after we do the 320, we'll do that, Jennifer. You got it. So you are third in the queue. You go 201, we'll do another 201, then 320, and then Jennifer's bar chart. You got it. So in which section is that? My quiz only has 5 questions. It's supposed to have. Oh no, I just pulled them all up, Caroline. I pull up every single question. So I can see all the different versions, all the different possible questions you could get. So I pull up all of them. So I get all 15. And so right here we have p hat, and p hat is going to be equal to, once we find p hat, we can find what? Well, we don't need it actually, I lie. We need to find q hat. For this one, we need to find q hat, 59.6. We need to find q naught. Sure, we'll do it this way. There's q naught. Okay. So we have here q naught. Q naught is 1 minus p naught. So let's go right here and go. This is the observed minus the predicted. So every time you do the equation, like even I had to pause for half a second just to kind of let my brain spin up. You're doing what you observe in a sample minus what you expect according to the null. So the top is just a difference. The way to just remember it, like just keep it in your head, is to be like, it's just a difference. You're just taking what did we observe in our sample minus what did we expect. And that's then going to be standardized by the bottom. And the bottom, why don't we use p hat? A lot of people wonder, like, why aren't you using p hat right there? Awesome. Let's do that. You use p naught because on the bottom, because you're assuming that is true. So we are using p naught, and look at this. This is going to be ridiculous right here. So this is why I already know a few answers to this one. I've done it a few times anyways. But when we do this, people wonder if that's a 9 a lot of times. My 9s and 4s look very similar. Does anyone know what the z-score, like, don't worry about a number, but is the z-score going to be very large or very small right here? Just look at the distance and just think about, is the z-score going to be very large or very small for this problem? So look at the distance these two are away, which when you get a statistical eye for these things, you can start to be like, ooh, that's a big difference. Probably the z-score is going to be what? You don't want to just look at it, though, because we haven't standardized it yet. So when you start to see things like this in statistics a lot, you can be like, ooh, that's pretty big right there. But what is pretty big? That takes a lot of problem solving. It takes a lot of like working multiple problems to be like, that does look like a pretty large difference. And then when you standardize it, we need to square root it, right? There we go. There's the bottom of the equation. So now we're going to take the top, which I'm going to redivide 1115 divided by 193. There's that number, but with all the decimals, minus this. There's the difference. There's the z-score, negative 18.193. Now, that's ridiculous. That is a ridiculous z-score. Let's draw out. So this was just step 2. Step 1 was write their null and alternative. We haven't done that yet because I'm debating it. If I get one wrong on this problem, it's going to be the null and alternative. It can be that large, Jessica. Yep. This one usually solves out to a ridiculous z-score. So usually this one, I've solved it a few times. Usually you get a ridiculous z-score. I'm going to ask you guys about the null alternative. You've already done it. I'm like, woo. So when you solve this, you're going to get something way, way over here. And I'm trying to remember. See, they're going to trick me here if they do this. So what do you think the z-score is about equal to? If we do to the left, or if we do to the two-sided, the z-score is about equal to this for what? It's about equal to 0. There's about no area to the left of this, or to both sides if we do the as greater than. I'm so 50-50 on which way I want to choose it. Okay. So the alternative right here, they don't really give a preference, but they're saying how they rarely lose luggage. This one's gotten me many times. I'm too afraid I'll come back to it. Determine the z-score. The z-score is this. Let's copy paste it. I don't want to start today with a wrong answer. Not today, my person. Not today. Find the p-value. The p-value is 0. You might be wondering, how do we do that? Well, we go to the David M. Lane applet. Let's let the David M. Lane applet pull up right here. They're asking if it casts doubt on the airline's claim. And the way I always think about that is the airline wouldn't, because my brain says, well, the airline would be happy if it was like, if we say it's not equal to this. So here's the David M. Lane. Let's bring over to the page. And we're getting the answer of 0 right here, but we're just going to show it. We're going to go the area below this. That's 0. If it's the two-sided alternative, which two-sided means you shade both sides, we would do the area outside. It's still 0. So no matter what, if we do the below or the two-sided, it's still 0. And we drew a little graphic of this on our screen. Where's our graphic? We drew a little graphic to show kind of what it looks like, and there's no area. It's the probability of this is basically impossible. So we'd be saying right here, this sort of z-score, this sort of observation just can't occur by random chance. That's what the p-value here off the curve means. It's so far off the curve, it's just basically impossible that this would be happening. So do the results of the survey cast doubt on the airline's claim? Yes, the null is rejected. So yes, since the null is rejected, that looks good. That's what, is that the, wow, it's the same answer. Mike Pearson, you got to get better at this. Okay, so we're one answer away from acing this. We're one answer away. Are the assumptions met? Is it random? Is it less than 10%? Is it doesn't say random, which I wish it did. So is it random? Is it less than 10%? And do we meet success failure? We definitely meet a success failure. To check success failure, we need to go 0.93, which is P naught, and then times that by N. So there is how many successes we would expect. And then 0.93 or 0.07. Wake up, brain. And then times that by 193. So we do have enough failures. So we have enough successes, and you use P naught, NP naught, NQ naught for that. So the only thing we have to do now is get this alternative correct. The only thing we have to do. And I'm going to go for this. This is the left-tailed test. And if it's wrong, we're going to immediately change it to the other one. You ready? We got it. So I always try to, I start second guessing myself. But when you think about this, the airline claiming that they have greater than, so we are trying to find evidence that the airline is not meeting this standard. I wish it said that, like, this is the standard. Maybe I'll go in and recode this. It's hard to recode my Pearson questions. But I wish it said, is there evidence they're not meeting the standard, which is this claim right here. They claim they have 93%, and we might be trying to show evidence that they are not meeting the standard. So we wouldn't want to show not equal to, because not equal to would mean, well, it could be less than, it could be greater than. So we only want to show evidence it's less than the claim that they're putting forth. So that makes sense right there. I just double guess myself. It doesn't give strong enough wording up here, but just thinking about it theoretically, we want to show evidence that less than this is what they're having. And then we have one more my Pearson one. Let's see here. What is the other one? After this question, can you do the chapter 5 about the organization that monitors aspects? Yeah, let's do it. Startup company, a radioactive fallout, amazing stuff. Let's do an organization monitors. Political campaign, here we go. An organization monitors many aspects of elementary and secondary education nationwide. Their 1996 numbers are often used as a baseline, like a null hypothesis, to assess changes. In 1996, 39% of students had not been absent from school. In 2000, the responses from this many, looks like a sample size to me, randomly selected students had slipped to 38%. And then there's an important part to this question right here coming up. Let's highlight it. So we're going to run everything over here on the side. It'll generally ask us these things because we're just doing a statistical test. So we have, do these figures give evidence of a change? So if we're asking, and that's the key word I think a lot of people miss, do they give evidence? And I like this. That is exactly what I like questions to say. So the null always has the what sign. Help me out here. The null always has the what sign. Every time I do a null hypothesis, it will always have the what sign. The null always have the what sign. These are the numbers we're going to talk about here. The null will always have a what sign. We're talking about students having perfect attendance. So when I write this, I'm going to write the null states that the true proportion of perfect attendance, and then I'm going to put the hypothesized value over here. And the same things carry through to the alternative. So when you do the alternative, you always carry through those two parts. And the null, nice job, Riley and Madison. And Maddie, excellent work out there. I'm giving out points this morning. Thank you so much. The null has the equal sign. And what am I going to put for the alternative here? The null has the equal sign. That's what we always need to remember. The null has the equal sign. Boom. There's the null. And then the alternative, we're just going to change the sign. We just write the null. And then when we get to the alternative, we just change the sign. And we're saying, is there evidence that it's changed? Now, you have to be careful because the number did go down, but we're looking for evidence it changed. So it says, do these figures give evidence of a change in perfect attendance? That's where it's like, wait a minute. We're just looking to see if the numbers have changed. So it does not equal. Great job, Riley. Yep. And so people get confused a lot of times because they kind of make clear, be concerned if attendance was like, of course they'd be concerned if it's declining, but they're looking for evidence it's changed. Do these figures give evidence of a change? Because people usually notice like, oh, it's slipped to this, well, they've gone down. So do we let the data, this is a good question right here, do we let the data guide our alternative, or do we let the research question guide our alternative? And the answer is we let our research question guide the alternative. If you were typing that, thank you very much. I usually pause, but I was going to continue the question. We let the research question, which is right here, guide it. We do not let the data guide our alternative. We don't say, oh, look at the data, let's pick the alternative because of this. No. We let the data guide our alternative. So, I mean, oh my God. We let the research question guide our alternative. My brain went on autopilot there for a second. Research question guides the alternative, not the data. Research question is highlighted. Only the research question is highlighted now. Research question guides the alternative. There we go. We got everything notated. So always notate everything. Get all your notation done. As soon as you have all your notation done, it should be more obvious which formula to use, especially for the test if we don't mark all the notation for you. But this is the good practice right here. So let's change. Let's get a green pen. If I change the pen twice, it won't do the magic color change on me. I figured that out. There we go. Because it always reverts to the last color. Oh my gosh. So P hat minus P naught Q naught over N square root. Got it. And so here we are with the equation. Let's go ahead and start plugging in the numbers. And P hat is going to be 0.38 minus 0.39, the hypothesized, and 0.39 times 0.61 over 8783. And that's got it. And there we go. Let's go ahead and solve this. Let's go 0.39 times 0.61 divided by 8783. And then square root. And this is going to be an interesting one. It's about 1.92 or something like negative 1.92. Yeah, there we go. Got it. Working in my head right there. Negative 1.92. Okay, so we have the alternative. We have the p-value. We have the z-score. We can get the p-value. We can get a good estimate of it. Let's see how we would have done. When we draw this out, so that's step 2 right here. We check the conditions, random, 10%, success, failure. Usually I go through the conditions a little bit quickly. Can you do the genetic abnormality? Yeah. We're going to do some 320, then do some project, and we'll come back to that. Adriana, you bet. In the queue, third in the queue. Thank you, everyone, asking the questions, especially right now. I'll try to keep them in my head, and then we will do all the questions. So I like to do a little sketch of what I think the p-value will look like. And we're right about here. So can anyone tell me, since we're almost at a z-score of 2, so we have to plot at the z-score of negative 1.92 and a z-score just as extreme of 1.92. Does anyone have a guess that this p-value might be a little bit bigger than this? A little bit bigger than this percent. Think of your 68, 95, 99.7 rule, and you'd be like, oh, the z-score might be a little bit bigger than this. We'll show it here in a second, but I would say the z-score is probably a little bit bigger than this. This is a decent test question where we could put multiple choice. And that's where I think people usually get stuck. They're like, well, how could we do this on the test? Which is a great question. And it's like, well, we could give you multiple choice. And if there was an answer that was close to just a little bit bigger than 5%, I'm going to say 5.4%. 5.4%. That's my guess. My guess is 5.4%. Oops, that's not the z-score. 5.4%. 5.5%. How did I know that? Because inside of this is 95, and then outside of this would be about 5%. So it's very, very close to a 95% confidence interval. So I know 68, 95. So this is basically 2. So if 95 is inside, 5% is outside. So my guess was about 5.4%. And we wouldn't put too many answers close to that. We'd put like 2%, 5.4%, 16%. So we'd put answers that if you graph it, or if you know the empirical rule, is going to be pretty obvious that when you look at it, you're like, okay, wait, this is very, very close to a 95% confidence interval. We know with the 95% confidence interval, this is 5%. There's an answer that says 5.4%. That's the answer I'm going to pick. So it was 5.5. Very close, very close. How many decimals does it want? We have here that the null has the equal sign. The alternative is does not equal, because we're looking for evidence of a change. Are the conditions met? This is basically your random and independence. So it's plausible. It's definitely plausible that they sampled less than 10% of all students. We do have more than 10 successes and more than 10 failures according to the null. That is mathematically met, because 39% times this and 61% times this is more than 10. Find the z-score. How many decimals? Ooh, I would have gotten that. There's the z-score right there. That's correct. And then the p-value, 0.055 rounds to. State your conclusion at the 0.1 alpha. So how do we reject the null? When do we reject the null? What is the point of alpha? So do I reject the null here, or do I not reject the null? We should know how to use alpha. Alpha is just a bar. So all alpha is a bar. And then what do? All alpha is a bar. Alpha is just a bar. So we look at that bar at 0.1 and we say what? And you can pick any alpha. You could pick 0.2 alpha, 0.3 alpha. We generally don't do this. We generally don't do it. My Pearson just wants to make sure you know when, if people do it, and if what it means. Do I reject the null here, yes or no? And why do we reject them? Do I reject the null, yes or no? You can just answer that part. And why do I reject the null? You only need to answer the first part. We reject. Great job, Edward. We reject the null because it is less than alpha. Alpha is just a bar, it's not literally a bar, but just think of it as a limbo bar. So we reject the null when the p-value is lower than alpha. So whenever your p-value is lower than alpha, when your p-value is low, you reject the null, and you say there is evidence. So if you reject the null, there is evidence that it changed. Great job, Edward Riley, right there. If you reject the null, there is evidence it's changed. But if you have a high p-value, you do not reject the null, there is not evidence it's changed. So always remember those phrases. I reject the null, there is evidence for the alternative. I do not reject the null, there is not evidence for the alternative. So there is evidence it has changed. This difference is very small. This goes to practical significance. So we talk about that in line 320. This difference is probably not meaningful. The observed change in sample is quite small. So even though it is statistically significant, it does not indicate a large enough change to be meaningful. This is literally the idea of practical significance. Woo, I get scared right there. I wonder if I would have guessed this one correctly. That was my guess. Oh, would have gave it to me. Yay! That was my guess right there. So I should just went by my guess. Here we go. Let's do a little 320 right here. And I think, do I still have 320 up? Here we go. 320. Can we find the z-score for the question about the... Yeah, of course. I think people want that one next after... we have bar charts after this, and then we can do that one. You bet, Riley. So hang out. We got this. Let's do this. And Kayla was wondering about starting with the data set contains. I'm a bit confused. Then a brief look at data set contains. Okay. Which one? Which one, Kayla? Starting with what the... Oh, you're saying, like, what does the data set contain? Okay, yeah. So what it is they're looking at the quality of wines right here. And let's see, let's run up the... this is EX6 wine. Good questions right there. Okay. A data set with 2,700 observations of the 12 variables. So you've got just different metrics of different wines. So adapted from the wine quality data set at UCI Data Repository. In this case, the original quality of the wine had been scored from 0 to 10. We've changed it to high, low, and chloride's treated here as a categorical variable instead of quantitative. They've got some more stuff right here. Let's bring this up right here. 2 data sets are included related to red, white Vinho Verde wine samples from the north of Portugal. The goal is to model wine quality based on physiochemical tests. So these are physiochemical tests. And it looks like they have 2 data sets here. So this is a bigger data set. They've got 12 variables. They donated the data set. Number of web hits. Holy moly. It's got 1.5 million web hits. Hey, Maddie, good to see you here. Good to see you here, Maddie. So here's the source that we have. The 2 data sets are related to red and white variants of Portugal, Vinho Verde, wine. For more detail, consult web link. Why does everything send us to another website? It's like, go to this website, go to this website. Vinho Verde. Okay, cool. I don't know where that brought us. Due to privacy and logistic issues, only physiochemical inputs and sensory the output variables are available. There's no data about grape types, wine brand, wine selling. So they're not telling us which wines these are. Yeah, we were doing some just a moment ago. We're gonna be back here doing it in a moment, but yeah, hang out and we will do it. So these are the variables. Does this help make sense of what it is, Kayla? So this to do comparing the quality and chemical compound. Yep, different wine samples. Great questions right here. So yeah, it's just different wines. And they took in, people. What it might be, because I think people are sampling the wines and then people rate the quality of the wine. So outlier detection can be used to detect a few for wines. Also, we are not sure if all input variables are relevant, so it could be interesting to test feature selection models. Cool. These data sets can be viewed as classification or regression tasks. So classification is what we're doing right now. Logistic is classification because we're doing, like, is it this group or this group? Regression is fitting a line. So you literally have predicting probabilities or predicting lines. That's just what they're saying right there. But good stuff on the data set right here. I haven't been putting cuts in today. Future Brian's going to be mad at me. We can do an example from a different data set. Yeah, let's talk about the interaction next. So I'm going to put a cut in the video. Cut in the video. Future Brian, I'm sorry. When you're doing the cuts in the video tonight, you're going to be like, what were you doing, man? You're not putting in cuts in the video. That helps you out so much. Why'd you do that? I don't know. Let's get this going right here. Okay. Let's go over. Okay. There, I'll be able to find this one. Okay, let's do an interaction right here. And we were doing an interaction yesterday. I've already got one up. Okay, let's take a look at this. Here's an interaction right here. So let's look at the model first. And in your assignment, you're not doing, it's not on a categorical variable. Good. I mean, you're not doing logistic for the interaction. Oh no, Jacob, just keep looking for a spot. And I am teaching it this summer. So if you are okay with summer courses, I think there might still be summer seats. So, but if you don't want to take summer courses, don't do it. Don't do it. And we got some 320 going on right now. Let's take a look. So, Kayla, right here, which of these lines is the reference line? Because I think this is the way I did the interaction on this one. I did it on a categorical variable, but you're still doing a quantitative Y prediction. So, yay, thank you, Kayla. Kayla, let's throw some positivity points out here. Kayla, you're awesome. Which of these lines is the reference line, Kayla? And then we'll talk about how to explain this. The female's the reference line, exactly. You can tell because F comes before M, and also it's the black line. Black line's the reference line. So there's lots of little small details to give this away. Now, what do indicator variables change? What does from the reference to the indicator only? Like if I did not include this, what does an indicator variable change? Like if I do not include the interaction, so there's no interaction, here's interaction. Here's no interaction. Oh, I can just do this. Here's interaction, no interaction. No interaction, no interaction. Here's no interaction, here's interaction. So with no interaction, they always change the what alone. No interaction only changes the what. So with no interaction, it'll change the what? The intercept, exactly. So exactly. I think you're saying it right there. Good to see you, Gina. So with no interaction, we just see the intercept being changed. With an interaction, we get the intercept and the slope changed because it changes the way in which height. Exactly. I realized that when you put the second one. So with no interaction, we have just the intercept being changed, and within interaction, we see the slope being changed. So the way in which height explains someone's weight depends on someone's gender. The way in which X1 explains weight depends on someone's gender. When someone is female, the slope for somebody's height, which explains their gender, let's go look at the summary. The slope, when they are female, would be this right here. The slope, oh wait, we don't have the interaction. Bring the interaction back. The slope, there we go. When someone is female, the slope would be this right here. So this is the slope of the line when somebody is female. But the slope will be water when somebody is male, because now if they're male, we'll put a 1 in here. So this will become 1, and then these like terms will combine. And give me an estimate of the coefficient. And actually, it's a really nice, if you look at this right here, the slope for males, the slope for the height of males, or the coefficient for height of males, which is the slope of the height of, the coefficient for height for males, which is the slope of the male line right here, is going to be very close to what? And you can see it because there's really some nice numbers. It's not going to be exactly that, but it's close. Exactly. We got some nice numbers this time to do that with. It's basically that. You round it all down. It's basically that. And I'm always like, if the numbers are close enough, it's good enough, because we'll let the computer do most of the work. And so you can see that the female line is 2.48 and the male line is 3.5. And so there is a stronger relationship. That's what I would say lastly, is there, after I quote these numbers, I'm giving some really thorough analysis, I would say that height has a stronger relationship in predicting the height of males than it does females, even though both have a positive relationship. Does that make sense? There's a stronger relationship with height to predicting weight for males as seen by the increase to the slope of the already positive line. Things like that. Like I've said a lot right there, but using sentences like that, like comparing the two together and talking about the two lines. Actually, do you want to do one more part of this, Kayla? Because then we'll hop back around. But I'm sure 320 is going to be very happy to. And then I also wrote out the equation right here for female. And if we do the equation for male, we just take this and we're going to increase the slope by the male right there. There's the male slope. And then we also change the intercept. We need to subtract from that. So sure, we'll take. You might be like, these don't look negative, but they go off the screen. And that should be, because they get that ends at 50 right there. They go off the screen. Yeah, what do you want to talk about? Feel free to ask. Yeah. So here are the male and female lines. This is an important skill set also to have, is to be able to take this output right here and to write the line. So make sure you know how to do that. Like, especially for the final, make sure to know how to write the implicit lines. We've been doing a good bit of practice of that. We've had a few write the implicit lines, just practicing that. You just go, it's, this plus this times this, plus this times this, plus this times this. And if you see things like gender male, if somebody is male, then you would do it right there. He'll do. You should know how to, everyone should in our class know how to write the implicit lines. So let's just go predicted weight. It's going to be this. Well, I can actually just take all that and take this and times it by, so this is the line for everybody. We'll just times it by male. This is the line for everybody. And then height times male. Make sure to know how to do stuff like this right here. This is the line for everybody. For part 4, task 1, will we use VS? Yep. Yep. I think that's about the issues of, because there's going to be some multicollinearity. So that's, and you'll see the high if you've already done it and you've noticed it. There's super, I think it's like 25 or so. I think I left the code in there by accident. And I'm like, maybe I'll go delete that. And then last night I forgot. So yeah, using the VIF, and I think I also put in the answer key on purpose. And so yeah, the VIFs are really huge. So there's the lack of statistical significance is probably due to the high multicollinearity caused by the variables being created from interactions. Interaction variables, since they're created from variables, and we've noticed this with like singularities being created, if you just take two variables and add them together, you get a singularity, because that means the information contained in the new variable is already just a aggregate of the previous information. So you're not bringing new information. So you get the singularity where the model has complete overlap in the variation brought by the variables. I love statistics. It's so cool how the mathematics overlaps with like linear algebra and linear independence and all this stuff versus dependence. And so you get a lot of interesting stuff. So the multicollinearity, how the x's explain the x's, is a big, it's an issue with interactions, because and that's what we're seeing right here. There's going to be multicollinearity in this model because usually these variables are significant. And oh yeah, look at that. I mean, the interaction is causing huge multicollinearity. That's some multicollinearity right there. I mean, that's ridiculous. A good test question right now would be about how many times has the standard error increased? About 22 times if I don't have a calculator, something like that. Because all you do is you square root this and 22.6. So you just square root that, and you can use your calculator, obviously, but that is about how many times the standard error has increased, 22.6 times or so. The standard error has been vastly increased, and the standard error is our uncertainty. So we do not like that. We do not like that. That's not good. Let's see right here. We'll hop back to 201. Thank you, Kayla. Excellent work. Excellent job. I look at the videos and I'm like, man, my hair has gotten longer, because we've got the Everything is Fine video playing right now. Not right now, but during class. I think there was a question about bar charts. We're going to do bar charts, and then we'll hop back to doing the Pearson stuff. So can you go over the write-up for the bar chart in Project 2? Which bar chart are we doing, Jennifer, if you're still here? You're welcome, Kayla, anytime. Am I biased against the data set of this? Usually I wouldn't. Wait, are you biased? I guess usually I wouldn't care, but this week I do. As in, what do you mean? Like, oh, you mean because it's like wine, and you're like, I actually just... I sorry, I don't know. It's like I'm trying to understand. Yeah, let me know. Oh, I am biased. Yeah. I'm so confused. My brain's still waking up, Kayla. My brain's like, what's going on? I don't understand. I don't understand statistics. Let's hop back in. Part A, I was hung up on the word. Yeah, of course. Is this section 2 right here? Section 2, right? Let's go ahead and take a look at section 2. Let's do this. Create a bar chart of the variable weather. Your bar chart must be displayed in horizontal. Include the values, either counts or percentage of the bars. Take a screenshot of the output, bar chart, and frequencies. And include a short write-up of the different levels. So we'll go in right here. And let's go ahead and let's grab a categorical variable, like somebody being born in Tennessee. And we're going to go here to analyze distribution. Now I'm using a different data set than you, so that way I can just do different stuff. And we're going to grab this right here. We're going to go to born in Tennessee. We're going to double click it. Could you go over the chapter 15? Yeah, I think so. I think that's everyone's wanting the birth question next. I think you got it, Edward. And so we've got this right here. We're going to then go to, no worries. Oh, no, yeah, sorry. No, that's what, no, yeah, no, I think it's all right to have bias, especially in that way. We'll click the red arrow right here, and we'll go to stack. And so we go to stack right here, and there we go. Now I like to expand this a little bit right here. And so we go and do this right here, and we have it. And we go right here and go to histogram options, and we go to, oh, it's off the screen, and go to count access with count access right here. And then we go to the second red arrow. We go to histogram options, and we go to show counts. Now I'm going to put a video in the chat. Someone's going to be watching this and saying my numbers don't show up, and that is true with some of the way the settings can be. Oh, here it is. Cool. I've got the night mode.
If you're having an issue.
Yes. Pass Brian, explain it. So there's an issue with night mode. And night mode, we'll go right here. And so with this right here, night mode has we have a video in the chat right now, how to fix night mode, how to fix numbers not appearing. And there we go, how to fix the numbers not appearing. And so we have everything we need. We have the probabilities. And from here, we can just kind of talk about it. We can say from this graphic, we see that 39.948%. I just carry all the decimals when they appear. Percent of people are not born in Tennessee. 60.052% of people are born in Tennessee. This was 761 people not born in Tennessee and 1,144. Just generally, there's not too much to talk about for this one. So include a short write-up of the different levels. Yep. So usually I'll quote everything I can. I'm one of those people who just like does everything I can, but that's got it. That's how we do the bar chart right there, kind of talking about it. And if the numbers don't appear, we've got the fix right there. Let's do the vital statistics. I hope that helped out right there, Jennifer. Does that answer everything? Let me know if it doesn't, and we'll hop back to this. But there's the bar chart, and there's the explaining it. Make sure to take some great screenshots. Let's do this. Okay, a vital statistics report. I think, is that the birth rate one? I think it is. People are wondering about the birth one. So let's see. Yeah, awesome. Great job. Yep, here's the twin one. No, great job, Jennifer. Excellent work. I need more coffee. I am 2/3 done with 1 cup. More coffee, more coffee. Okay. 10 cups of coffee a day. No, you're not supposed to have more than, I think, like 3-ish. Not saying it's the end of the world if you do, but what's the guy? There's a really cool doctor on YouTube. He does a bunch of stuff about like crazy medical cases. He has a video where he's like, don't have more than this many. One of the medical cases, some guy drank 2 pots of coffee in like an hour. 2 pots of coffee in an hour, and that's not a good idea. I mean, the pot of coffee, that's a lot. 2 pots of coffee in an hour, something like that. It's a little much. Little much. Body's not really meant to, yeah. It's a little much. So we'll go right here. We have, I know, right? I know. He's pretty good channel. He's pretty interesting medical stuff. So we have a vital statistics report indicates that 3.8% of births produce twins. We then collected data and only found 10 sets out of this many. So what do we have notation-wise right here? I'm giving some hints right there. I'll find this one. That is correct. There we go. What do we have notation-wise? I'll write the rest of this. What do we have notation-wise? So we always want to remember what the notation is. It's always good practice. P hat is the sample proportion. P naught is the hypothesized proportion. Q naught is the complement of the hypothesized proportion. And N is the sample size. A lot of times you'll forget what X is. So we have here P hat equals X over N, which is the number of successes over the number of trials. So what notation do we see on the screen? Because it's like, okay, wait, how do we get to where we need to get to with this? Because I think that's where people usually get stuck. It's like, what components did it give me of what I need? What do we have? Coffee. And this is always the practice, especially when it comes to problems. I am excited about the day when we have written tests again. I don't know. I guess, will we ever? Nice job, Andriana, right there. Yep. This is 10, x equals 10. So x equals 10 and n equals sample size. X equals 10, n equals sample size. Great job. Yep. And that is, we need practice. It's all about practice. 10 divided by 435, 0.023. And so P naught, where's P naught? Wait, there's P naught. I lost P naught. And I was like, where is it? I seriously couldn't find it for a second. My brain was just like, what? And let's go right here. There we go. And we need to save that for later. Yeah, we're going to lose it. We're solving the bottom of the equation right here. So we're going to solve the bottom of the equation. And now we take... I'm going to redivide this to get the number. I'm big about carrying my decimals. There we go. So we just solved this all out right here. If you have to write down numbers as you go, that's all right. But I always use copy-paste. And we have solved for the z-score of negative 6.37. I like that. Negative 1.637. So this is near a z-score I know, which is why I like it. When we do this problem right here, it's going to first ask us, are the assumptions met? Are these a random sample? Are they less than 10%? Do we have at least 10 successes, at least 10 failures? We should be pretty good. And you might be looking at this 10. That's not the 10 we're looking at. We actually want to look at according to NP0. So the condition is actually NP0. So that's how we would check it. So we need to go 435 times, and truthfully, this is the only one we need to check because it's a smaller one. So according to the hypothesized proportion, we have at least 10 hypothesized successes. Since we're doing a hypothesis test, we use NP0. This would actually be NP hat right here. That is NP hat, but this is P0, and we times that by N to get NP0. So that's NP0 right here, and that does pass. NQ0 would also pass because NQ0 is going to be the much larger one, just to show NP0 and then Q0 add up to 100% of the data. So 0.962, which is Q0, times 435 is the larger portion of the failures we expect, the not twin birth rates. So what is the null alternative? We're going to ask, is it the same, right? I think that's what this asks. Is the rate of birth rates the same? So we're going to pick the does not equals alternative. If all the assumptions are met, get the z-score. We just found the z-score a moment ago, and we deleted it out of the calculator. What was it? 0. Here we go. There it is, negative 1.64. Okay. Negative 1.64. And now, find the p-value. This is the fun one. I always like finding p-values. I always like thinking about them. This p-value should be a little bit more than 10%, like 10.3%. So could we have done it to 3 decimals? About that. Let's go ahead and take a look. And we'll go to Mr. David M. Lane applet. Do we still have it up? We do. David M. Lane right here. Let's go in and put it in the chat. There's the chat. And let's go to the outside. Negative 1.64. And it's 10.1%. 10.1. I was close. That might not have gotten it. It might have said no to me. It might have said nope. So now we have to ask, using a 0.05 alpha, do we reject the null or fail to reject the null? So when the p-value is high, just let it fly. When the p-value is low, reject the null. So since this p-value is high, we're just going to let it fly, which means we fail to reject the null. There is not enough evidence for the alternative. Would we have gotten this with our guess? The answer is we would have. We would have guessed it correctly. We always like to show our work and show our answers. And the reason I know this is because I know the p-value, or I know the z-score of 1.645. So when it was close to that, I knew it was a little bit more than 10%. So that's how, if anyone's wondering, how are you able to guess that? I know the z-score for a 90% confidence interval is 1.645. And so then I just said, well, it's going to be a little bit more than that. And I'm shocked it's not. I'm really shocked it's. I'm actually going to go look at that and jump. So it should be Q norm. No. Q norm. Yeah, it's really about that. Yep. So there's down to the decimal place accuracy of what it is. So it's really, really, really very close to that. So, was it? It was 37 something, wasn't it? 637. What's the next decimal? Oh, it's closer to mine. It's closer to mine. Or it's between mine and what is when you round the decimals. So it's 10.3%. I was seeing how close it was. 10.2, 10.3. I said 10.3. It's 10.2 when you round all the decimals and you carry the decimals we didn't carry. So that's got that right there. Was there another? We did the twin one. Let's hop back here to space. What questions are there? Like trying to, I'm just going to hit the microphone. Like trying to take guesses on those. Let's put on music. What other questions are there? Thank you, everybody. Really good work this morning. There we go. Where's my music? You're welcome, Edward. Which ones? If you have another one, let me know. We can do another one right here. We're going towards the end of All Stars. Can you do the genetic abnormality question? Adriana, you got it. Let's see. I'm looking back up here at the top. The nonprofits. Would you like the nonprofits or the genetic abnormalities? Because I think we haven't done either yet. My background broke again. The nonprofit one with dropouts. Let's do the genetic abnormalities. I think we can do both right. Let's do it. So, Adriana, which one? I know you asked about genetic abnormalities, right? Congenital abnormalities. Let's go find that one. We got enough time. We always got time. Congenital abnormalities. Political campaign. All these dictator questions. Here we go. Congenital abnormalities. Let's go do it. I hit the wrong button. Okay. Got a little music playing. Some 1980s. We like the 80s. It was generally believed that congenital abnormalities afflicted about 6% of a large nation's children. No nation mentioned. Yeah. Chapter 15. Tons of problems. Some people believe that the increase in the numbers of chemicals in the environment has led to an increase in the incidence of abnormalities. A study examined 419 randomly selected children and found that 45 of them showed signs of abnormalities. Is this strong evidence that it has increased? We consider a p-value. What are they telling you right here? They're telling you they're what level? Put on music. They're telling you they're what level right here? We consider a p-value of 5% to represent evidence. So what are they telling you right there? They're telling you they're what level? So when they say we consider a p-value alpha, great job, Riley. Yep. They're saying this is the point at which we are going to say we have evidence. They're just saying alpha equals this. So that's just alpha equals this. We could just summarize alpha equals this. That's what we know right there. We see some other general statistics. Let's go ahead and copy paste this. I guess we would write the null alternative. Okay, so the null always has the equal sign. Ooh. So they got a lot of options right here. So it is generally believed this is going to be the hypothesized proportion. So that means we are down to this choice, and this choice. Because I think so, right? Yep. Has it increased? So then we've eliminated down to the 0.06, so it has to be this one. Great job, Riley. Yep. Because 0.06 is the hypothesized, and they're actually telling us right here p hat. So when we find p hat, we can actually get p hat, which they're showing us by kind of giving away another answer. That's p hat. So they're using p hat instead of p naught. That's an error people often make, is they put p hat here instead of p naught. But p naught is the hypothesized proportion. That's not the right answer, but p naught is the right answer. Like, so that does have the right number there, but has the wrong sign. Aw, Samson, so good to see you here. Thank you so much. Let's throw out some 100 points. Make today even better. Samson, we appreciate you swinging by. Ask any questions if you got them. So we have here p hat. Let's go ahead and copy paste the question. You know what? I love the positivity people bring. It's one of the best parts. is like we just chill, get some work done, drink some coffee. Students have asked me like, what's your favorite part of teaching? And I'm like, probably office hours. Because we're so relaxed. Used to be we would bring candy. But you know, we're in a crazy time. So we can't bring candy. It was bad. I'd eat so much candy. It's like the candy bowl would get drained and I'd be like, I gotta stop eating all this candy. So sometimes I'd see candy I really wanted and I wouldn't buy it. Because I was like, if I buy this candy, if I buy like York peppermint patties, I'll eat all of them. One time, we had Lindor truffles. That was bad. I'd eat like 10 Lindor truffles during office hours. I would be like, Brian, did you eat truffle yet? I'd be like, yeah. And they'd be like, here, do you want another? Like, I'd be like, yeah. I mean, they're mine. But I'd be like, oh man, just sitting around eating candy, doing statistics problems, eating candy. That's the life. So we got all the notation marked right here. Let's go ahead and what's up, Bryce? Good to see you here. We're just like listening to some music. Nice piano music. There we go. So there's the z-score. The z-score is going to be found by taking the sample proportion minus the hypothesized proportion over the hypothesized proportion, the complement of the hypothesized proportion over the sample size. Just the more you practice these, the better you get at just knowing the formula and knowing what goes into it and identifying the notation, which is kind of key to these. So I think it said this is... Need to buy a piano. There we go. And let's go ahead and we'll worry about that later. Bottom part of the equation being solved for. And yeah, we're going to go full decimal place accuracy. We don't go any other way here. It's the only way to go. Full decimal place accuracy. I think we did everything properly. 4.08 or 4.09 when you round it. So that's 4.09, which means we know the p-value now. How do I know the p-value? Well, when we graph this out, we're 1, 2, 3, 4. There's the p-value. Does anyone have a guess at what the p-value is going to be? If we were at a z-score of 4.09, what do you think this p-value is? Brian's going to guess for the p-value. Free mailing labels? I think we might, Katie. I think we might. We got enough time here. We got all the time. What do you think I'm going to guess for the p-value? If you look at that visually right here, and if this was a test, what would you guess? Because we have the greater than alternative. That's, if you're wondering why did we shade to the right, our null is that the true proportion is equal to 6%. The alternative hypothesis was that the true proportion is greater than. And when we have this, always look at the way the alternative shades. The alternative shades to the right because it's greater than. So that p-value there is going to be basically 0 because there's no area under the curve, which is what the p-value denotes. Check the assumptions. The independence condition is satisfied. Basically, it's random and independent. It's random. Less than 10% of the population. There are more than 10. Good, they're not trying to trick us here. Oh, they just go straight to the p-value. Let's check our p-value just to make sure. So we're going to do greater than the z statistic. Oh, that's not the z. There, it's 0. It's 0. Where did the good question, Parker, right there? That came from. Let's show it. Here we go. So that comes from this right here. Thank you, Parker, for asking that. There we go. Does that make sense? The p hat is the number of successes over the total number of trials, and so that is going to be right there. You guys might not be able to hear. You can hear the music. Good. So that is how we get that. Yeah, no. Ask all the questions. That's what we're here for. Like, you guys know I'm always pausing, like being like, how do we do this? How do we do that? And I'll pause for a while because if you answer all your own questions, people will stop answering your questions for you. If I keep answering every question, students won't answer them. So thank you, Parker. Let's throw some 50 points. Parker, thank you so much for asking questions, because I'm here to not just to work problems, but to answer questions related to problems. That's the goal. When you see something you don't know how to do, you just say, hey, Brian, what does that mean? How do you do that? Number 4 on the homework. Which one is that, Ansley? We might have time. We got like 15 to 20 more minutes. We got like 15 more minutes. So we might have time. We got a few more in the queue here. We will try. We might have done it today, Ansley. We might have done it. So if you can tell me which one that is, we'll see here. Explain carefully what the p-value means in the context. It's the probability of observing this or a result more extreme occurring by random chance variation given the null is true. So the p-value is probability of observing 45, which is the observed result of genetic normalities in a sample of this. If 6% is true, that states that the null is true. I think we just did that one. Is that the one we just did? We just did that one about 5-10 minutes ago. So rewind the video, Ansley, and check that out because we got a few more we're going to do today. But check out just a few moments ago. If you can't find it, let me know. What's your conclusion? The p-value here was very small, right? Let's look at that p-value. Yeah, it's 0. So since the p-value is small, p-value is low, we're going to reject the null. So we reject the null. There's evidence for the alternative. Always remember the phrases. I reject the null. There's evidence for the alternative. I do not reject the null. There's not evidence for the alternative. I've written that out lately. You can go through all the different classes I've been teaching. So I reject the null. There is evidence for the alternative. I do not reject the null. You know we do this the easy way, right? I do not reject the null. There is not. So notice the small changes right here. We say I reject the null, there is evidence for the alternative, or I do not reject the null, there is not evidence for the alternative. So you either reject the null, there is evidence for the alternative. Looks like I'm minusing them. Or you do not reject the null, there is not evidence for the alternative. Just making sure you see this right here. This is how we speak. So we say I reject the null, there is evidence for the alternative. Or we say I do not reject the null, there is not evidence for the alternative. I do not reject is the same thing as I fail to reject. I fail to reject the null. Same thing right there. I just like saying I do not reject the null. So that's the only things we can say. So I reject the null, there is evidence. Do environmental chemicals cause? Yeah, exactly. We can't talk about cause and effect in statistics. We are on a roll today. I don't know what was up with me yesterday, I think it was Monday and Wednesday. Today's Thursday. I don't know what day today is. Today's Thursday, and just made a few mistakes on a few problems, and picked the wrong alternative and stuff like that, and things go haywire. Let's go see which other one did people want. Let's go take a look. The other question was the mailing label. So I think we have mailing labels. Can you go to the top? Yeah, let's go look at that real quick again. There's the top of it right there. I think people wanted the mailing label one. We see mailing labels, and I think in which other one did people want? Nonprofit concerns. We did the nonprofit concern. We did Adriana's, right? Yeah, we did Adriana's. And then, can you do the one formulating null hypothesis? Yeah, sure. How does it start, Maddie? Got time for like 2 more, maybe. We can do that one, Maddie. We're just trying to do. So, how does that one start, Maddie? Tell me how that one starts, and I'll find it real quick here. We'll do that one. I don't have any music. Music. Nice chill music. Which one? Write the null hypothesis you would use to test each situation. Okay, got it. Here we go. What? Come on, buttons. Can't hit the buttons that quickly. So we have a dictator. Don't know why they're concerned about negatives if they're a dictator. That is the percentages of a country's residents who express disapproval of their job performance. His political committee pays for a series of TV ads, hoping that they can keep the negatives below 45%. They use follow-up polling to assess the as, yada, yada, yada. The null always has the what sign. The null always has the what sign. The null always has the what sign. They want to keep his negatives below this, or her, or theirs. We don't know who they are. So they want to see if they can keep it below this. The null always has the equal sign. So you know what we can do? Equals, equals, equals. So the null always has the equal sign. Like we got 3 questions right. So they want to see if they can keep it below this number. So to keep it below this number, great job, Leslie and Maddie. To keep it below this number, they're going to do an alternative. They're trying to find evidence what? They're trying to find evidence what? They're trying to find evidence. If they're trying to look, they're trying to see if it's below this number. Like, can we show evidence that we've kept it below this number? So to show evidence it's below the number, we're going to do which one? Because they want to say we have evidence that the true proportion is which one of these right here? Because they're trying to keep it below this number. That's what they're trying to show evidence. They're hoping to show evidence for. Well, it's not going to be equals because we already know the null has the equal sign. Yep, 100% right, Maddie. Great job. Less than, because they're trying to show it's evidence of less than. Great job. So is a 10-sided dice spinner something fair? Let P represent the probability the spinner lands on a particular section. So we're going to say basically the null is that it's fair, that the probability it lands on a particular section is 10%. And then the alternative will be that it's not fair. It's either fair or not fair. So to do not fair, we would say that it is either lands on this 10% of the time or it does not land on it 10% of the time. So it is either equal to 10% or not equal to 10% because this would be fair and not fair would be it doesn't land on it. Well, I'll let everyone figure out this next one. We know the null has the equal sign. Only about 22% of people who try to quit smoking succeed. Sellers of a motivational tape are trying to help people succeed. Let P be the proportion. So they want to show evidence that they will help people succeed in smoking. So they want to show evidence that their messages can help people succeed. So they'd want to show the true proportion of people who quit smoking is what to 0.22. So they'd want to show evidence. If they want to show evidence that their tapes are helpful. Exactly, Ansley. They'd want to show evidence that's greater than. That's another 100. We're just on a roll today. Just going awesome. Getting questions done. Let's see right here. Was there another one people wanted to do? What other ones do people want to do? I'll pepper back here to space. Let's pick. We've got time for one more. One more. Be teaching here in about 20 minutes. Can you do the what about the number? I think we did that one, Melissa. We haven't done mailing labels yet. Can people confirm we did the dropout rates? I think we did dropout rates, so it is in this video, and you can rewind this video live. And then which one's the homework one, Ansley? Can you name off the homework one? I know you're saying do the homework one. And then is it the twins one? We've done the twins one. So I'm trying to do as many as we can. With the Z-score, I'll look at that right after. We'll do the nonprofit. We'll do the mailing label one. And then thank you, everyone. I'm just trying to get as many in the video as I can. We're going to get the mailing label one done because we haven't done that one in this video today. So I try to do as many different ones as I can. Okay, we haven't done the mailing label one, so let's go do the mailing label one. Awesome. So we're going to try to do... We might have time for one more of this. Okay, here we go. So a philanthropic organization sent out free mailing labels to 100,000 potential donors. So everyone help me out. If we can blaze through this one, we might have time for another one. So we gotta get this one done quickly. You ready? I need notation help. Everyone knows Brian always needs help with the notation. So help me out with the notation in the chat. I'm gonna try to get 2 more done, like this one and 1 more. So help me out. Oh, well, look at those numbers. Those are the most beautiful numbers I've ever seen. My Pearson's even trying to help us out and being like, Brian, you got time for 1 more after this. I need help with the notation right here. I'm going to start writing the formula down below to solve this. So while I write the formula, go ahead and start telling me notation. Go ahead and start telling me notation right here. Start telling me all the notation. What notation do we have? So there's the formula to test the proportion. And they want to see... But a staff member... They worry that it'll be lower. So, but a staff member worries that the rate will be lower. I think definitely, yep. I think we know that. All right, great job, Katie. So, and actually, Katie points out that this is going to be P naught then. That's P naught is equal to 0.05. And Q naught, and don't get those confused with like alpha or things like that. It's just happenstance that we have that. N, great job. I'll do the rest right here. So there's N, and here's X. X over N equals P hat. P hat is equal to this. We don't need Q hat. So look at us flying through this. Look at us. Boop. Good stuff. Let's go ahead and solve for the z-score. Ooh, don't do that to me, scientific notation. 0.000689. 0.00, you can't copy these, which is a bummer. No, do? 0.000689. There we go. Negative 2.9. There we go. P-value is going to be about 0.3% or so. Yeah, about 0.25% or so. Very, very small. And let's go find that. So we're just going to take this z-score right here. We're going to do the less than alternative because they're concerned it will be lower. So we'll go ahead and graph that. So we need to go below the z-score following, and it's about 2. I should just guess 0.2%. I was pretty close to that. And let's go back. Here we are. So they're concerned that it might be lower. So if they're concerned it will be lower, they're looking for evidence it is less than. So remember, the null has the equal sign. Are the assumptions met? Randomized 10%. So we have random. We have independence, which they sometimes split apart, but if it's random, it's independent. We have here success failure. We have at least 10 successes, at least 10 failures. We expect 10%. So that'd be... No, this is right here. Excuse me. We expected at least 10 successes. We expect 5,000 successes, and we expect 95,000 failures. The 10%, probably less than 10%. Oh, what? Wow, it doesn't actually have us put in the p-value and all that. So the p-value I got here is very, very what? The p-value I got here is very, very what? Look at the p-value, and you can see it visually right here. This p-value right here is very, 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 very low. I hate that too, Leslie. Leslie's talking about scientific notation. I'm like, no, just put the zeros. I don't want to deal with scientific notation. My p-value here is very low, so we're going to reject the null. Since the p-value is low, the p-value is low. The p-value is too low. The p-value is low enough to conclude that the rate would be below the previous campaigns of 5%. Look at that. Just awesome today. Which one are we going to do? Say it quickly. Which one? As long as it's one we haven't done today, we can get it done. So we've done all of these ones right here. We've done 6 full questions today, talking about everything. In a jury trial is generally that they are not guilty. In a hypothesis test is equivalent to which conclusion? So not guilty would be failing to reject the null hypothesis. Which of the following hypothesis has an appropriate null? Null always has the equal sign. The probability of seeing sample data like those or ones less likely given the null is true is a p-value. Probability of our results or results more extreme occurring by random chance variation given the null is true. Look at that. We got done. That's how many we got done. Some speed run of those right there. What other ones should we have time for? Maybe I'll speed run a question right here. I will speed run a question. If someone names it, even if it's one I've already done, I might have to reload it. Is your time? I have to speed run it. We have to pull out all the statistical knowledge and speed run it. All the knowledge. Every last bit of knowledge. If we can get one here quickly. So many questions. That is a tricky one. Wait, which one, Maddie? Which one was it? Was it the one I was previous on or this one? I got like 3 minutes. Airline Obolic? Which one? I'm running out of time. The radioactive fall. Okay, I think Maddie said the radioactive fall. Okay, here we go. Okay, I'm gonna try to do this. I'm not gonna show all the work for this. This is gonna be super quick. I've literally got like 2 or 3 minutes. Okay, you ready? Here we go. I have to speed run this. Let's put on a little speed run music for Brian to do this right here. Okay. Radioactive fallout, yada, yada, yada. There were 240 people in the region, and 36 of them died of cancer. That's X, that's N. Cancer estimate that one would expect 31. That's the hypothesized proportion right there. Is this death rate unusually high? Are the conditions met? Sure. State the null hypothesis. This is the null value right here. The null has the equal sign. Is this unusually high? So is it unusually high? So they want to know if it's greater than, because they're asking if it's unusually high. Determine the z-score. Okay, so they actually just gave us p-naught right here. P-hat is that. So let's first find out the standard deviation of the distribution. So let's go take p-naught. So this is p-naught. You're about to see p-naught right here. There's p-naught. There's q-naught. P-naught times q-naught over n. Where's n? That is the standard deviation, square root. Always forget square root. There we go. Now we need to subtract p-hat minus p-naught. It's the top part of the equation we're solving. So 36 divided by, this is p-hat. There's p-hat minus p-naught. There's the difference. There's the standardized difference. There's the z-score. Z-score is right here now. I'm going to take a guess at this last one because I want to super speed run it. So the p-value is going to be a little bit more. Oh my gosh, that is ridiculous. But you know what? Ridiculous is what we do. There we go. Is the observed death rate unusually high? No, because the p-value is not. The p-value is too high to include the death rate is unusually high. Does this provide evidence? That's weird. We didn't get that. A little bit concerned about this. Does this provide evidence whether the death rate is unusually high or not? This cannot be determined. Let's go look at the p-value right here. Sure, let's have an amazing day. Dang it. P-value must be wrong. Is the other one wrong too? So let's go above this. 1683. Did it really take off that many points for this? What is the other one? Going way too quick here. Two decimals. It should like this. Yeah, that's fine. Oh, no. That's, no. I read that way too quick. They should just ask. So I did the p-value by guessing it. Oh no, I gotta go. I did the p-value by guessing. I thought about 16% in my head, but this way this was asked. The p-value is high. We fail to reject the null hypothesis. So I misread the last part. Speed reading this. The p-value is high. The p-value is high. We fail to reject the null. We do not have evidence for the alternative. Once again, whenever the p-value is high, we fail to reject the null. The p-value is high. I fail to reject the null. There's not evidence for the alternative. So just the way they're phrasing it right there. So this is for p-value greater than 0.05. Be very careful reading the questions. This is for p-value less than, greater than or equal to, technically. P-value less than 0.05. I think that's got it. Speed run of question right there. We will be back later today. So if you didn't get your question here today, if you didn't get your question in this morning, I will be back later. I'm going to go send out the announcement, get ready for class. But I will see everybody later. Sorry about those one mistakes. I'm sorry. I was trying to speed run it. I'll be back later, everybody. Someone's like, what just happened? Bye, everyone.